talk where we were before the midterm, or we started reviewing for the midterm, because it's probably been like 2 weeks before since we've talked about similar triangles. So I won't go into everything we've done. All right, I'll talk more about that on Thursday when we review for the test. But where I need you to be successful today, we did proofs with similar triangles, statements, reasons, where I said prove these two triangles are similar. And we noticed that the main method, we had 3 of them, or 3.5. I don't want to go over all of them, but the main method in a statements, reasons proof was angle, right? Find 2 pairs of angles, they're similar. So that's what we did in the statements, reasons. And then the following day, we said, all right, we're getting pretty good at this. I can find 2 pairs of angles in the triangles, they're similar. And now I asked you to prove this, that AB over ED equals AC over DF. Prove that's true. So what we did was like, all right, that's not going to be true until the triangles are similar. So again, we proved the triangle's similar. And then we said, all right, now the triangles are similar, the corresponding sides are in the same ratio by a method we call CSSTP. And that's where we cut off the unit. Okay, that's where we cut off the unit. Kind of remember a little bit, because now what I'm going to do is we're going to prove triangles similar. Then we're going to prove the sides in proportion. Then we're going to take it one step further. What's after this? Okay, that's where we're going to go today with you. All right, that's where we're going to go today. So before I do that, though, I do have a couple vocabulary terms for you, but I got a question before I show them to you. 6 over 12 equals x over 5. How would you solve that? And I'm going to do a much, much better job this semester calling on people, so you're making sure you're focused. How would you solve that? Let's go here. Going back. Maddie, how would you solve that? Cross multiply. Darn right. Nice and easy. Cross multiply. But here's the thing. When you cross multiply, you would start let's say you start with the 6 and the 5, which is correct. They actually have a name, though. The 6 and 5 have a name in that proportion, and that's my new vocab for you today. When you cross multiply, all right, going downhill left to right, going downhill left to right. So in this case, the A and the D here, you end up multiplying what's called the extremes of the extremes of the proportion. All right, those are called the extremes when you multiply the 2 values going downhill left to right. And when you multiply the other 2 values going uphill left to right, you are multiplying what's called the means. All right, the means of them. So those are the new vocabulary terms I want you to be familiar with, because it's going to come into the theorem today. All right, downhill, I'm multiplying the extremes. Uphill, I'm multiplying the means. Let me go back to my proportion there. So I do that. I get 30 when I multiply the extremes, and I get 12x when I multiply the means. What do I do with them? I just leave them hanging. What do I do with the 30 and the 12x when I multiply them? What ends up have to be in between them? Juliana, what's in between them? An equal sign, right? I set them equal to each other. And that's the theorem I'm going to show you today, is the product. And that's hopefully not a new vocabulary term. That's what you get when you multiply 2 numbers, right? The product. The product of the means. The product of the means, which I'm going uphill. Juliana just said put an equal sign, so the product of the means is equal to. Anybody think you want to finish it? Product of the extremes. Got it. Product of the means equals product of the extremes. And unfortunately, I hate to break it to you, there is no shorthand. Please don't write POM equals PO. All right, there is no shorthand for this. So you do have to write it all out. So that's a new fact that we're going to write in the reasons column right now. That's a new fact we're going to write in the reasons column. All right, so welcome back to proofs. Here we go. If you need to mark up the diagram, go right ahead. I'll give you a minute to mark up your diagram, because all the givens are already written in there. It's an isosceles triangle. I tell you the 2 congruent sides, and there's a couple right angles in that diagram. All right, let's look at this proof statement now that you have your diagram marked up. Everyone see I'm multiplying sides and setting them equal. So this tells me it's somehow going to be a product of the means equals product of the extremes. How do I get to that point, though? All right, how do I get to that point in the proof? Well, for me to have means and extremes, don't I need a proportion to have means and extremes. And if you keep working backwards with me in this unit, how do I get a proportion if the two triangles are similar? Yeah, so here's our plan, guys. I need two triangles to be similar first. Then I need their sides to be in proportion. Then I'll cross multiply and tell you the means and extremes are equal. But I need a pair of triangles similar first. And I don't know about you guys. I'm not even going to try to count how many triangles are in that diagram. So which two need to be similar, right? Which two? I'm just not going to pick and pray. How can I tell which triangles need to be similar? Look at your proof statement. What I need you to do right now, either by yourself or with your group, talk to each other, is find me two triangles containing those four sides. And they got to be full sides. These four in the proof statement have to be full sides in the two triangles you pick. So see if you can find them right now. Because we can't move on in the proof unless we know what two triangles we need to prove similar. Find me two triangles that contain those four sides, but they have to be full sides, though. ER, AD, TE, and DT have to be full sides in the two triangles you pick. All right, did we find the two triangles that I'm going to try to prove similar to get moving here? Let's talk here. T, do you find those two? There you go. I like it. Triangle ERT needs to be proven similar with ADT. Those are the two triangles that contain those four sides. Good work. All right, I talked earlier. The only way we're going to, in a statements reasons proof, is angle. We're going to get triangles similar. So now I'm going to leave it up to you guys. How can I find two pairs of congruent angles? I'll take the easy way first. They told me TER was a right angle, and they told me ADT was a right angle. There's my first pair. Step two. Tell me those two are equal. You're welcome. You didn't need to tell me they're right angles. I already told you. TER congruent to ADT. All right angles congruent. All right, one pair down, one to go. Where's the other pair of congruent angles? Use your givens. There's one given we haven't talked about. We already used the right angles. The first given we did not, though. So where's the other pair of congruent angles? All right. Maddie, back to you. You see any pair there? Angle RN. You're not going to call it angle T because I'm going to ask you which one are you talking about, right? Could be like three angle T's up there. Which one are you looking at? Name it with three letters. There you go. All right, so we got angle R congruent to angle ATD right there. Those two, yes, those are the second pair. I know Maddie knows, but I'm going to ask somebody else why. So angle R congruent to angle ATD. How do we know those two angles are congruent? How do we know those two angles are congruent? Juliana, back to you. Why are those two angles congruent? Machine. I'll leave out the isosceles part, but it's correct. Keep it in a triangle. Congruent angles are across from congruent sides. Good work. I have angle. So now the triangles are similar. Just write me a correct statement in the correct order now. Write me a correct statement in the correct order. Triangle ADT. Actually, you know what? Never. I'm going to ask you guys because I said I got to do a better job calling on you, making sure we're alive. There we go. We don't even have a 19. Yeah, we do. Rayhan, sorry. Name any triangle any way you want. You got an easy job. RET. All right, so we'll name that yellow triangle up there RET. Make sure it's similar, not congruent. All right, so if I go RET, Rand's going RET on us. How can I name the green one up here, or the second triangle on your diagram? If I go RET, okay, I got it. RET, and we're going, there we go, Rowan, RET, and TDA. Looks good to me. All right, I got angle now. I am not jumping to the proof statement, because what did we say we needed for the proof statement? A proportion. So now that we know the triangles are similar, we know the sides are in the same ratio. How do we build this ratio? Correct one, because I just don't want you throwing sides up. We're going to use our proof statement. Look at the first two sides in the proof statement. You need to multiply ER and AD. You have to. So either make those your means or your extremes right now. All right, so where should they go in your proportion? They got to either be your means or extremes to multiply them. So either you put it right here, ER and AD, or you put them in the other two spots. Okay, you have to be able to multiply them, and you cannot multiply them if both of them are on top or both of them are on the bottom. Okay, they need to be diagonal from each other. They need to be the means and extremes. And then TE and DT. And this is what we called what right before we started reviewing for the midterm. If the triangles are similar, the corresponding sides are in proportion. Little shorthand for that one. I have it. I got it. T.
I forget.
It's all right. It's all right. It's been a while.
Oh, CSSTP.
There you go. Yep. CSSTP. Now we could say the means and extremes are equal, but I need the proportion to do that. Now we can take this one step further and say, now I'll cross multiply. ER times AD equals TE times DT, and this is why you need that theorem. Product of the means equals product of the extremes. I always get the question, is it all right if we switch means and extremes? I don't care which one comes first. Means the same thing. All right, questions. I am not going to do the next one with you. You can do it by yourself or in your groups. You can talk to each other. I'll give you about 4 or 5 minutes to go through this product of means and extremes one. Again, first step, what triangles are you going to prove similar? And it looks like you're going to have to know your parallelogram properties here. So I'll walk around. If you have questions, just call me over. Got to prove the means and extremes are equal again on this one. Take your time. Which triangles do I need? And those 4 sides that are in your proof statement, they have to be full sides in the 2 triangles you pick. Remember, it's got to be full sides. properties of parallelograms we need to remember for this one. And if we don't want to do it, we don't have to. No big deal with me anymore, second semester. Sink or swim. Just so you don't go down I don't want you wasting your time let's make sure we have the correct triangles first here. I don't want you to start doing the proof and you have the wrong triangles. First one's QRC and the other one is APQ. Those are the only two triangles that contain those four sides as full sides. So those are the two you need to get similar right now. Okay? I want to make sure you have the correct ones before you start it. S and Q. Okay, so the opposite ones. Yeah. But it wouldn't be in the other one, right? This full one isn't in. Yeah, I got where you're. So now you're going like this.
Oh,
Yeah, but I need what that's the line.
Parallel line.
And what you do, right? Gotta do the lines first. Which angles and specifically are we talking about? QP, the whole angle? What? RQP, this whole angle? But that's not in the parallelogram. AQ, okay, so this one and this one. Okay, and these not alternate, but they are, because they're in your parallel lines, right? And they're inside them. They're not outside them, right? Here are your parallel lines that you need parallel first, and then you can go those two. Yeah. What is that? I've never heard of that before. I see. You're talking vertical angles? Okay, that's fine, but here's the problem. That vertical angle, that angle right there is not in the big triangle. It's gotta be an actual, triangles have 3 angles, right? It's gotta be one of the 3 angles in that triangle, okay? That angle's not in the big one, right? That one is, I agree, but that one's not. But you need more, the thing is you need more parallelogram facts, yeah, that's why. Okay, I'm gonna give you another minute and we're gonna start talking about here, because we're finding, I'm seeing proofs where many of you are finding one pair, but we can't find another pair. And remember, it's a parallelogram. You have five properties of a parallelogram that you could use, 5. All right, let's talk about this. All right, let's talk. The proof I'm going to show you has all 3 pair. I know you only needed 2, but I want to make sure that in case I used 2, that you had the same 2 there. So I just put in all 3. First property I used was in a parallelogram, opposite angles are congruent. There's the big one. All right, opposite angles are congruent in a parallelogram. So that's how you get 1 pair. And I'm sure as I walked around, that was the main pair you guys get. And then we had a little struggle here. Now remember, also in a parallelogram, opposite sides are parallel. Okay, opposite sides are parallel. So I just put both pair down because I didn't know which one I was going to use. So I put both pair down. Everyone's good so far. Now, if I have parallel lines, what does that lead to? Alternate interior angles being congruent. And there's 2 sets up here. You could use either set or both. Here's 1 pair, angle RQA, this one right here, with QAP. Here's 1 set of alternate interior. All right, here's 1 set. Might want to copy that down if you have a blank proof. If not, okay, no big deal. All right, everyone see the 1 pair, but you had to tell me the lines were parallel first. Or the other pair, take a peek. What do I want to use here? I'll go red. The other one was angle C with angle CQP, the one up here. Those were alternate interior. All right. Yes, King. Hey, what do you have?
Do you have to say that like the opposite sides are parallel?
Yes, because parallel lines imply alternate interior angles congruent. Correct. Alternate interior angles not congruent unless you have parallel lines. And again, you don't know which lines need to be parallel. I always tell you, put both down. Put both. So I put both pair of alternate interior. I know, again, make sure we're good. You only need 2 out of those 3 in your proof. You don't need all 3. I'm just showing all 3. All right, you only need 2 out of 3. So either the opposite angles and a pair of alternate interior or both pair of alternate interior. And then once you have that, you have angle. Please, everyone that got to this point, please check your proportion. Are you cross-multiplying the correct ones from the proof? You should be cross-multiplying QC and QP and AQ and CR. Make sure you're cross-multiplying them and they're both not on top or the bottom. So that's how you get a second pair out of this. All right, I know it goes on to the homework. I'm not confident, though, in the homework tonight. The first 2 are proofs. You guys should be good with that. We just went over 2 proofs, so the proofs are fine. We do need to review, though, the whole algebra stuff, so I'm going to do number 3 with you right now. All right, and we'll get a homework problem done. Number 3. Here you go. I'll leave up. If you guys still need to copy that down, go ahead. You guys that are on to number 3, start the diagram for me. start drawing the diagram for number 3. We got to review a few things about the algebra part. All right, I'll get my diagram up here too, and we'll talk. All right, we got our diagram marked before we set up our proportion. 2 weeks ago, before we started reviewing to the midterm, I gave you this thing called the side splitter theorem. All right, and I want to know, can I use it here to do, and I wouldn't write this down, by the way, here's side splitter, x minus 1 over the other part equals 4 over x plus 6. Is this a diagram I could use side splitter on? It is not, right? It is side splitter, not the base splitter. Remember what we said. If you are given the lengths of the parallel lines, you can't use it. Okay, you can't use it. If the 4 was here and the x plus 6 was here, yeah, this would be a fine proportion. Okay, you cannot use side splitter unless the sides are given and not the lengths of the parallel lines. All right, so that's out. So let's try to set up a correct proportion here. Let me start with somebody. Give me a side from triangle ABC that you know. Let's start with a full side. Rowan, how about a side from ABC?
X minus 1.
All right, you got it. X minus 1. So I'll start with that. Rowan is giving us side AB. So now all I want to know is name the side in the bigger triangle that matches up with AB. AB matches up with what in the big triangle? Just give me the name of it. AB and what side? There we go. Jackson, AB and? AD. All right. Now I know I need to put side AD there. How long is side AD? Well, part of it's x minus 1 and part of it's 1. Combine those and I end up with how long is side AD after you combine those two partial sides? Combine the two partial sides. Mia, how long is it? Just x. And if you're wondering where Mia got x from, we did x minus 1 plus 1 and combined our like terms. Good job. All right, let me get rid of that. Put that in black. All right, now give me another side from triangle ABC. What's another side from the smaller triangle? We're almost there. Where am I going with that one? Jayla, another side? 4, which is BC. And what does BC match up with in the bigger triangle? BC and what other side here? Zoe?
DC.
What is it?
DC.
DC is not a side.
DE. Sorry.
DE, yep, DE. And I don't need to ask anybody. That's already labeled as x plus 6. Any questions on making the proportion if I can't use side splitter? Now we got to solve. Means and extremes time, right? Cross multiply. X minus 1, x plus 6 equals 4x. Remember, double distribute, FOIL, whatever you called it in Algebra 1. All right, distribute the x, and then you should be distributing the negative 1 and combining like terms when you can, and it'll ask somebody what you have there. When just combine all your like terms for me. What do you get on that left side after you double distribute or FOIL? Double distribute or FOIL. Halo, what do you have there?
X squared plus 5x.
X squared plus 5x minus 6. Everybody good? Any questions where we're getting that from? You should end up in the middle with a 6x and a negative 1x. Okay, I'm sorry, guys. I can't. That's all Algebra 1 stuff. We went over it on day 1, too. We can't stop and review all that. You know you're going to have to factor, but can't do that unless it's equal to 0. So next move over the 4x. X squared plus x minus 6. Now this comes up down to your decision now. Do you want to try to factor it, or are you going to immediately go to quadratic formula? That's your call. That is your call. In here, we're going to try to factor it right now. All right, I'm looking for two numbers that multiply to negative 6, but add to 1 at the same time, whatever tricks you guys have. But tonight on homework, you want to plug it in the quadratic formula. Go ahead. Just make sure you get 2 answers. Numbers that multiply to negative 6, but are going to give me a 1 in the middle. I'll get there eventually. Sydney, you got any numbers for me? 3 and? Good job, yep. 3 and negative 2 are the only ones. 6 and 1, don't cut it. It's got to be there. 3 and negative 2. All right, now we go to our answers. X equals negative 3 and x equals 2, but we have to always be aware if there's a diagram, I need to reject an answer if it gives me a negative side. Do either of these two give me a negative side? Yeah, negative 3 does, right? If I plug negative 3 in for AB, can't have a negative 4 side. So that's rejected. And I'm just left with 2. Questions? All right, I'm just looking at number 4 now. When you set up the proportion for number 4, make sure you use your statement to find what sides match up. And if you can't factor it, what do you have to use? Like we could factor this, it was nice, but sometimes I'm looking at number 4 in particular, you won't be able to factor, so we have to use quadratic formula. All right, and get 2. Remember, you should always have 2 answers out for these, 2 answers. You might reject one, but you end up with 2. All right, all you.